This is the homework helper for Chapter 8, Section 6 in the 7th grade workbook, Classifying Triangles. So, in the top part of the worksheet here, questions 1 through 9, they're all asking me to do the same thing. They're asking me to label each triangle according to its sides and angles. So let's talk about the different opportunities we have here for answers. Every question will have 2 answers. As far as talking about its sides, there's some different answers that exist here. We could say that the triangles here are equilateral. Equilateral implies that all 3 sides of the triangle are the same, meaning all 3 sides have the exact same measure. We could answer here that the triangles are isosceles. When we say that the triangles are isosceles, what is implied is that the 2 sides of the triangle end up being the same. Or we could end up saying here that the triangles are scalene. Scalene implies that none of the sides are the same. Now, when we look at these set of questions up here, 1 through 9, we don't see any numbers marked on the sides. So all of our answers here are reliant on the hash marks that they put to the triangles. And we've seen the hash marks already in Chapter 8. Remember, what the hash marks indicate is congruence. If we have 1 hash mark through something and 1 hash mark through something, we know they're the same. We don't know what they are, but we know they're the same. So if we look at question number 1 and talk about its sides, as we can see looking at this left side here, 1 hash mark, looking at the bottom side here, 1 hash mark. That implies that this triangle has 2 sides the same. And if it has 2 sides the same, we're going to answer that this is isosceles. Looking here at question number 2 has the exact same feature. This side that's drawn, I guess we call that the top here of the triangle, has 1 hash mark. And this side here that's at the bottom or the right side of the triangle, whatever you want to call that, that also has 1 hash mark. That indicates that these 2 guys end up being the same. So if it has 2 sides the same, again, same answer, isosceles. Finally, looking at number 3, no hash marks are present. So if we're taking a look and answering this question based on the number of hash marks or sides that look the same, none of the sides look the same because none of them are the same. And again, we could use that same logic here in 1 and 2. The sides that both have 1 hash mark in them kind of look like they'd be alike because they are. Question number 2, this top and this right side here, or top and bottom side, they both kind of look the same because they are. Here, none of the sides really even look the same. So here, we're going to end up answering that this is a scalene triangle because none of the sides are the same. Alright, so now we need to go back and talk about the triangles based on its angles. And there's 3 different answers you can give here. And we've seen these names in a different section, but not based on this context. 3 answers here. One of the answers is acute. When a triangle is acute, that means all of the angles are less than 90 degrees in the triangle. So all the angles have to look smaller than that L or T shape. We can answer right here. When we say a triangle is right, it has 1 90-degree angle. Now the other 2 angles in a right triangle are actually forced to be acute. If you think about logic here, we can talk about it. Triangle has to make 180. If it has exactly 1 90-degree angle, it can't then have another. Because think about it, 90 and 90 make 180, and you'd still be an angle short. The only way you could have 2 other angles in a triangle if one of the angles is 90 degrees, if the other 2 are less than 90. Even if the other one is 89 degrees, that still leaves you a 1-degree angle to work with for angle 3. But if it's 90 and 90, that's 180, and you're short an angle. And then obtuse. Obtuse here implies that you have 1 angle greater than 90 degrees, so bigger than that L or T shape. But your other angles then are going to be forced to have to be acute as well for the same logic we used there in answering, talking about right angles. So if we take a look at question number 1, look here at this bottom left angle, we see that upside down L there, that indicates right angle. Well, if we have a 90-degree angle, that means this is a right triangle. So we've now completed by question number 1 by saying it's an isosceles right triangle. Taking a look at question 2, we don't really see any markings here on this triangle, but they certainly all do look to be less than that L or T shape. That means this is an acute triangle. So number 2 is an isosceles acute triangle. Taking a look at question number 3, we don't see any markings on number 3. Again, if we had that right angle mark, it would be a giveaway. Now this angle here definitely looks less than 90. This angle here is definitely less than 90, less than that L or T shape. The angle we're concerned with is this one at the top. It might be easiest for some people if I turn this around so you can see it how you're used to looking at it, or how it might be easiest to look at it. And as you can see, looking at it from this way, if this is that L shape, it's definitely a little bit less than that classic L shape. And if it's less than that L shape, that means it's an acute angle, meaning all 3 angles here are acute. So that means when we're talking about answering number 3 here, number 3 is going to be a scalene acute triangle. Now as we scroll down to the bottom here, in question 10 and 11, you have a conglomeration of triangles in both illustrations. And what they want you to do is tell me how many different types of triangles there are in the figure, and then name them. So as we take a look at number 10 here on the left, which I'm about to do with you, you'll do the same thing in 11. We see here we've got this triangle at the top is one triangle. The triangle here at the bottom on the left is a second triangle. This triangle over here on the right side is a third triangle. And then you've got the larger triangle over here, both of these guys together is triangle 4. So you've got 4 whole triangles here. So let's start with triangle number 1. Triangle 1 has 2 sides that are marked the same, so that means it's an isosceles triangle. Remember, isosceles implies that 2 sides are the same. But all the angles do look to be less than that L or T shape, so it's an isosceles acute triangle. Number 2, this one here at the bottom now, even though we have this mark left over from the one at the top, it doesn't follow down to any of the other sides in this bottom triangle here. And with that being said, that means this has to be a scalene triangle, implying that none of the sides are the same. As far as the angles there, we're looking for anything that looks bigger than that L or T shape. And right here, I do see that this angle would be bigger than that L shape. And if it's bigger than that L shape, that means it's an obtuse angle, meaning this is an obtuse triangle. As we talk about triangle number 3, this one over here on the right, we can peg the angle right away. We see a right angle here, so that means this is going to be a right triangle. As far as sides here, we don't see any sides that are marked the same here, so we have to assume they're all different. They all do kind of look even different, even though these two don't look like they would be terribly far off from each other. They're definitely both longer than this guy, but they're not marked the same, so they can't be the same. So that means this is going to be a scalene right triangle, another scalene triangle. And then as we take a look at number 4 is the entire triangle there on the left side. That's this bigger guy right here for triangle number 4. Well, if we take a look at the sides, we do have that one that was marked in with this top triangle here, but this one hash mark doesn't carry over to this side or this side. So since none of those sides appear to be the same, that's a scalene triangle. And looking at the angles, I don't see anything that looks bigger than 90 degrees, so that means it's also an acute triangle. So it's a scalene acute triangle. So 4 very different types of triangles here. Really, we have repeating features, but no triangles that end up being exactly the same. There's only one isosceles acute. There's not another one in the list. There's only one scalene obtuse. There's not another one in the list, and so on we go. And you'll do the same thing in question 11. Obviously, number 11 has a lot more triangles to name, but also it has a lot of repetition, as we can see looking at that illustration 11. These guys on the outside here all are the same. So naming these will actually, all 4 of these be the same. So you'll have one answer times 4 there for these outside ones. These 2 on the inside are different sides of a square, so those are going to be the same. So again, naming there, pretty simple. You should be able to breeze through question 11, even though it looks very complex, probably even quicker than we did question number 10.